Okay, so this time I'm going to ask you to think about some specific examples, classical test theory model. So, in the comfort of your own dorm or wherever you are consuming this YouTube ness, consider a construct that interests you. How is this construct operationalized? And what kind of measurement scale and results from it? Consider the possible score range and try to articulate X and T in your own example. And if you would like, you can count this as an engagement activity. And just write up a little spiel. All right, so next, let's think about X. What? Blah, blah. Next, let's think about E. Let's think about error. So, what might cause an individual's observed score, X, to differ from their true score, T, in this situation? Think about the conditions in which the test would be administered. Think about the population of students, patients, individuals that you are working with. Would they tend to bring some form of error or unreliability into the measurement process? These are important questions to be able to answer if you ever develop your own scale. Okay, so here I'm going to give us an example because, well, vague, vague concepts not super helpful. Okay, so in this research, we're testing children's phonological awareness by presenting them with a target image. So, for example, say an image of a star, and ask them to identify the image amongst three response options that rhymes with the target image. So, if you presented them with the image, which one rhymes with star? Then, for example, a child hopefully will point to the image of car out of these three image options. But as we know, measurement error in a test like this is going to be problematic. All right, think about our target audience. I mean, there are tons of reasons, but let's think about preschoolers. Preschoolers, in case you are unaware, are easily distracted. Even if we have standardized one-on-one test administration apart from the rest of class, children can and are easily distracted by seemingly innocuous features of the administration or environment. From the chair they're sitting in to the zipper on their jacket, which is a quite fascinating thing, to buttons, or cats, or anything else. Everything. So, in an absence of things in their environment, they'll tell you about things from home, what they've had for breakfast, what they did over the weekend, or as a last resort, things from their imagination. They will find ways to distract themselves. I can relate, in case you were unaware. So, second, toddlers have a really short attention span. So the test that they're administered has to be super brief and super simple. But shorter tests, as we kind of mentioned in that archery example, as well as like other sports examples, are less reliable. They have fewer items on them, which makes it difficult to identify the reliable portion of the measurement process. So for shorter tests, each like if you have a problematic item, uh, it's going to have a larger impact on the test as a whole, and there are fewer opportunities for errors to cancel out. So, think about what would happen to our error and the standard deviation of error if the tests were really short, like 5 questions. What would happen to error and its standard deviation if we increased the number of questions to 200? What might happen to the error and its standard deviation if we administered the test outside, or inside, or in front of a ton of cats? These are the types of questions that you really need to be able to answer when considering specific sources of measurement error and the impact we expect them to have, and whether that impact is systematic or random on our observed score. Because we may assume that error is random, but in reality, not so. There's a lot of bias. All right, so that is wrapping up model applications. Cool. And we're just gonna zip ahead. Apparently there are no cats. I don't know what their deal is. We're at home. Hello. All right. Well, let's see if I can summon one. I have a feeling that it's the time between shifts.